Okay, so the first step I did was I separated it. No fraction. We don't have a quotient rule, so I don't want a fraction. 3 over, so it's really 3 times, and then change the root to a power. Since it's on the denominator, it's negative. Fourth root means 1/4, negative 1/4. So the argument is 2x plus 5. That's u. Du, the derivative of that, would be 2. Solve for dx, 1/2. 1/2 du equals dx. Okay, my next step is plug in. So I have 3 times, that's my u. And then I'm going to plug in for dx is 1/2 du. Right? Well, there's no more x's. I'm happy. But I do have some constants here. 3 times 1/2 is 3 over 2. You can leave that on the inside, or you can just move it out to the front. It doesn't matter. It's not going to be involved in the antiderivative process. Okay? You're going to add 1 to the power, so negative 1/4 is going to become positive 3/4. Is that right? Yep. So I have 3 over 2, still outside. And then I have u to the 3/4. But I need to divide by 3/4, right? So dividing by 3/4 is the same as multiplying by 4/3. So that's what I'll end up doing. Multiply by 4/3 plus c. Okay. Some of these fractions reduce. That becomes a 2. That becomes a 1. That becomes a 1. That becomes a 1. So you have 2 u to the 3/4 plus c. Plug u back in. You were done? Okay. You are done. Okay. Let's look at it. Let's look at this guy right here. Very similar. Very similar, except without the fraction. It's already done for you. So I want you to try this one. Give this one a shot. Don't worry about the half sheet. The half sheet, that's the assignment I'm going to give you. If we don't get to it today, I won't assign it today. I just put it on just in case we were done early. If we're not done early, then we'll start it tomorrow. Okay, I just gave it to you just in case. So it hasn't been assigned yet. It will be, but not yet. Okay. All right, so the first thing we have to do is change the root to a power. 1/2 power 1 minus 4x to the third. So the argument is 1 minus 4x to the third. The derivative of that is negative 12x squared dx. Divide by negative 1/2 x squared. I get negative 1/2 x squared du equals dx. Okay. All right. So x squared stays because that doesn't have a u. The u is for the argument, so I put a u here, 1/2. And instead of dx, I'm going to put negative 1/12 x squared, and then a du at the end. The big thing is the x's. You need the x's. Any other letters, you want them to go away. I just want u's, and this one does it. Goes away. So we're left with u, negative 1/12 times u to the 1/2 du. This guy just move to the front and do your thing. So negative 1/12 times u, if I add 1, it's going to be 3/2 power, plus c, divided by 3/2. But instead of dividing by 3/2, instead of going divided by 3/2, what I'm going to do is multiply by 2/3. These simplify. So you get negative 1/18. Put u back in. U is 1 minus 4x squared. And there you go. Thank you. Okay.
The u is 4x, 1 minus.
Oh, third cubed. Should be a power of 3. Is that right? Yeah. Okay, perfect. Okay. All right. G is kind of similar. So I'm going to skip G for right now. We'll come back to it. But I'm going to skip it right now. I want to go to more like H is kind of similar too. We'll come back to those guys. I want to go to J. We've done a trig one, but I think we only did one trig one. So I want to do more trig stuff. Okay, we'll come back to the others, but for right now. So if you remember when we found derivatives, when I found derivatives of guys like this, the first thing I did was just personal preference. I don't like how they use powers in trig. It doesn't make sense to me. They put the power there. So the first thing I want to do is I'm going to change it to that. Is it necessary? No. But it's just for me. Okay. The next thing is I have to find out what is u going to be. What is u going to be? Well, there's two options. You have sine of x or you have cosine of x, right? You only have two options. So trial and error. Since sine of x is inside the parentheses, let me start there. If it's wrong, then I know my answer's cosine. Okay, so let me start there. Let's say this guy's sine of x. So that means du is cosine of x dx, right? Because the derivative of sine is cosine. So now I got to solve for dx. So divide by cosine of x, 1 over cosine of x. Okay. I know 1 over cosine of x is secant, but I'm not going to change it. I'm just going to leave it like that. Okay. So let me plug in what I got. So instead of sine of x, that's u. So it's going to be u to the third power times cosine of x is still there. Okay. dx. dx is now 1 over cosine of x du. Okay. And luckily, the cosines cancel out, right? So all that's left is no more x's. It's just u to the third power du. So I chose right. If I didn't choose right, then I would have chosen cosine as my u. That's the only difference. Okay. All right. So now we do antiderivative. So add 1 to the power, divide by that new power, plus c. Move everything back in. And you were done. Okay. The last one on we'll come back to the last two we skipped, but the last one you have, I want to do that one because that's an exponential one. For sure, I want to do that one. We did log. We did square roots. We did polynomials. Well, polynomials, you probably just use the power rule. Trying to think. Exponential is the last one that you're going to see. Exponentials are probably the easiest one. Why are exponentials probably the easiest one? They look difficult. You see letters like E, you get confused. Just your natural instinct. But why should you not be concerned about them? What's the derivative of e to the x?
I was about to say derivative of e to the x is just e to the x.
And so what's the antiderivative of e to the x?
E to the x.
So yeah, exactly. It's not anything, it's just the same. It's itself, right? They just look more intimidating than they are. Okay? So again, I have a fraction. If I was doing derivative, I would use the quotient rule, but I don't have the derivative. Or I don't have the quotient rule. So I'm going to put everything as is. E to the x times e to the x plus 1 to the negative 1 power. I have two options. I can make e to the x plus 1. I can make this guy u. Or I can make this guy u. Doesn't matter. Okay? Let's try one. Let's try e to the x plus 1. Let's try that guy. See what happens. So what is the derivative of e to the x plus 1? E to the x dx, right? Plus 1 goes away because the derivative of 1 is just 0. Okay. Divide by e to the x. Substitute. E to the x stays e to the x because I didn't do anything with the first e to the x. Times, parentheses, u to the negative 1. Oops, I forgot I can always for dx. Instead of dx, 1 over e to the x du. Okay. So I have two things with x's. Do they cancel out? Yeah. So I picked the right one. I ended up picking the right one. I'll know if I didn't if there's x's left over. If there was x's left over, then I know I'd picked the wrong u. Okay? So I have antiderivative or integral u to the negative 1 du. That's all that's left, right? So let's find the antiderivative. U to the 0 power over 0. Uh-oh. How do we do u to the 0 power? We talked about this, I think, a couple weeks ago, last week maybe. This is the only time when the power rule won't work. Why won't it work there? Well, we know why it won't work, right? If I add a power, it's 0. If I divide by that power, it's 0. That's undefined, right? Let me give you a hint. How should I rewrite that?
1 over.
Okay, so let's see. 1 over u du. Okay. The antiderivative of 1 over x, or 1 over u, or 1 over anything, a single variable. We've seen that before.
Natural log of u.
There you go, right? The derivative of natural log is 1 over x. The antiderivative of 1 over u, or 1 over x, is the natural log. So that's where we come in. So this is going to be the natural log of x plus c. Which is the natural log, and then we move it back in. Plus c. Now, sometimes when they do that, sometimes they'll have bars around it. Because that has to be positive, right? We can't find natural log of a negative number. It doesn't work. You want your calculator to get mad at you? Try to find, say, calculator, give me natural log of -2. It won't be able to do it, right? Because you can't, log means what power will make a positive number. There is no power that makes, or what power gives me a negative number? What power, like log, the meaning of log is any number. What number can I plug in there that would give me a negative number? Doesn't exist. That's not what powers do. Powers don't change signs. Powers make things really, really big and really, really small. But powers do not control negatives and positives, right? I would need a -1 out here to do that, right? So that's why the natural log of a negative number doesn't exist. There is no number you can plug in there for the question mark that would give me a negative answer. It doesn't exist. I can make it really, really small, and I can make it really, really big, but I can't make it a negative. So that's why sometimes you'll see, you're like, why are those bars around it? Like this one doesn't need bars because it's always going to be positive. If I plug in a power here, if I plug in a power for x, it doesn't matter if it's negative, positive, it's always going to be positive. +1, it's always going to be positive. But sometimes you'll see that. On tests, you'll see that. You'll be like, why do those have bars around it? Well, because they want to make sure that any number you plug in there is always going to be a positive answer. You're going to give you a a defined answer. Okay? All right, let's look at the ones we skipped. So G and H, do G and H right now. Those are more review of what we had done before. G and H, good practice. Okay, I'll give you about 5-10 minutes to do that, and then we'll go over those. Okay, so G, for letter G. I got 3/8 times the quantity 2x squared minus 1 to the 2/3 power plus c. Okay. Note first step, get rid of the fraction. Get rid of the fraction, get rid of the fraction. Powers only. And then you can kind of see what is your u. Okay. Letter H, same thing. doesn't have a root. It's already that root's already done. Instead of third root, it's already 1/3 power, but you need to break it up. 8x over 3 times the power, or times 8 minus 3x squared to the 1/3 power. Okay, so that becomes your u, and you go from there. And I got negative 1/3 times 8 minus 3x squared to the 4/3 power plus c. Okay. Okay, so the plan for today and tomorrow, the rest of today. Today we have about 15-ish minutes, is to start on the assignment that I gave you. It's not homework. We're going to work on it tomorrow in class as well. Okay? So you don't have to do it for homework. All I'm going to do tomorrow is going to give you time to do that in class because I want you guys to work on it in class. You can work on it at home if you want, but I'm also going to give you time in class tomorrow so that if you have questions, you can ask questions. I'm going to create a key and I'll post the key. I haven't posted the key yet, but I will. You're only required to do the circled ones. If you want to do more for practice, you can, but you're only required to do the circled problems. Okay? So yeah, that's all I have planned for the rest of today and tomorrow. Okay? Is that. All right. So let me work on a key.